Hello everyone, welcome to our class. This morning, what we're going to do is we're going to look at the homework problem assigned last time. Now I received quite a few messages that it was difficult, and I understand why that is. Largely, any example I give you is limited because there are an infinite number of possibilities that we can do, or an infinite number of problems we can solve using examples like, or using software like QM and Excel. The key though is understanding what's being asked. So what I'm going to do first, in the first section of this video, before we solve it later, is kind of break it down. This is something we did at the very beginning of this semester, but it's something that will come up again and again, because we have to read very carefully to determine what is being asked. So let's look at our question. And as we look, we'll kind of move through it and we'll try to summarize a couple things that we can see as time goes on. So Ronald Thump is interested in expanding his firm. For us, unimportant. After careful consideration, he has determined 3 areas in which he might invest additional funds: product research and development, manufacturing operations improvements, and advertising sales promotions. So this is important. What we'll do here is we'll highlight this. We'll write it down here. So we have 1, product research. Sometimes it's easier if we write it out before we begin working so that we understand exactly what's being asked. 2, manufacturing, operations improvements. And 3, advertising and sales promotion. So let's continue on. He has $500,000 available for investment in the firm. This is also important. Now the key here is that he has $500,000 available. Not that he will, but he has up to $500,000 available. This is important. So we'll bold that. He can invest it in advertising and sales promotion every year, and each dollar invested is expected to yield a return of the amount invested plus 20% yearly. Again, this is important. So let's look at the key information here. That's a bad color. Okay. So he can invest in advertising and sales promotion. So let's write that down here. Every year, 20%. And that is the relevant information. He can invest in manufacturing. He can invest in manufacturing operation improvements every 2 years with an expected return of 30% at the end of the 2-year period. Also important. Let's choose another color. Let's go with orange. So manufacturing every 2 years. 30%. All right. Now we'll continue on. An investment in product research and development would be for a 3-year period with an expected return on the investment of 50% at the end of the 3-year period. Also key. So let's give this another one. Let's go with yellow. So here, every 3 years, 50%. Now, we've moved through the first section. To diversify the total initial investment, he wishes to include the requirements that at least 30,000 in advertising and sales promotion, at least 40,000 in manufacturing improvements, at least 50,000 in product and research development at the beginning of the first year. This is our last key point. Let's go back to, let's go back to red. So product research is 50,000 first year. 40,000 first year. 30,000 first year. Ronald wants to know how much should be invested in each of the 3 alternatives during each year of a 4-year period to maximize the total ending cash value. Of their $500,000 initial investment. So we'll highlight our last section here and we'll say how much each year in each category to invest to maximize return on investment, or ROI. So here, what we've seen is we've gone through it and we've tried to write down as much critically important information as possible. So when we're formulating problems like this, and what we're going to do, I'm going to do it here in Microsoft Word. Please bear with me. This is not an easy thing to do in Microsoft Word because typos can happen, and when they do, it can get confusing. So let's go with the first one. First thing we have to do is write our objective function or profit function. One thing, as we've moved into Excel and as we've moved into QM, we've kind of forgotten about this. We have it in both programs, but we don't directly talk about it. So that's what we'll do now. So we have 3 possibilities, and each year, each of those 3 possibilities is possible. Now remember, in this section, this is theoretical. There is nothing governing our decisions. There is nothing preventing us from making any choice. That comes later with constraints. So to calculate our maximum return on investment, we have sales, we'll call it advertising, 1. X, advertising, 1. And that means, we'll type it down here. So X is the amount invested in each choice. So X advertising 1 plus X manufacturing 1 plus X R&D 1. That's for year 1. Plus, this is where it gets complicated because we have each of these 3 choices times 4 years. 3 choices times 4 years. We'll have a total of 12 decision variables. Please bear with me while I write that now. That's second year. Third year. So what we've done is we have our amount in advertising year one, plus amount in manufacturing year one, plus amount in R&D year one, plus amount in advertising year two, plus amount in manufacturing year two, plus R&D, amount in R&D year two, plus amount R&D in advertising year three, plus amount in manufacturing year three, plus amount in R&D year three, plus amount in advertising year four, plus amount in manufacturing year four, plus amount in R&D year four. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 different decision variables. Theoretically, each of those decision variables is possible because we haven't yet entered any constraints. We know that each of these decision variables is possible. The only thing we have to do now, so we have our objective function. Now to solve this problem, we only need one more step, and that is determining our constraints. That's what we'll do here. So we'll bold these again. And we'll do our constraints. So the first constraint that we're going to look at is that, let's do advertising and sales promotion first. So advertising and sales promotion, we have 30,000 first year. So how do we phrase that? We say X1 which is ADV 1 must be greater than or equal to 30,000. Now, when we enter it, and you'll see when I enter it in QM, we're going to do it a little differently than that, but the basic idea is that our minimum amount invested in year one in advertising is $30,000. That's it. C2. Oh, I should not have written an equal sign there. That could be confusing. C2, and that is X2 make it a little more clear. And X2, which is M2, is greater than or equal to $40,000. And that just means the amount invested in manufacturing, M1, sorry, not M2. In manufacturing year one must be greater than or equal to $40,000. We know that again from this statement right here. And then C3 is X3, which is R&D 1, must be greater than or equal to $50,000. Now, I'm sure everybody got this so far, hopefully. This is relatively straightforward. We have a couple now that are a little more confusing. So let's go to C4, and I'll try to explain it as we go along. C4 states that X5, which is M2, must be less than or equal to 0. And what I'm saying here is that any choices made in manufacturing, any money invested in manufacturing year 2, if it's above 0, that is impossible. Because we go up here and we see manufacturing operations every 2 years. He can invest every 2 years. So he's invested already in year 1. He cannot invest in year 2. It is impossible. So what this equation tells us is that any investment made in M2, manufacturing year 2, is impossible. That's what that's shown us. So what we do is repeat that one more time because we have one more year, C5, X11, which is M4, must be less than or equal to 0. And we see this because we've met if we invest in year 1, manufacturing, year 2 is impossible. Year 3, though, is possible. So if we invest in year 3, then year 4 also becomes impossible. So that's our fifth constraint. We're going to do something very similar with constraint number 6. And that is X6, which is advertising year 2, R&D year 2, sorry, must be less than or equal to 0. And we see that because we know that if we invest in year 1, manufacturing is every 3 years. So if we invest in year 1, then year 2 is impossible. Any money invested in year 2 doesn't work. It invalidates the question. It's an impossible situation. We'll repeat that again in C7, where we see that X9, you see here 1, 2, 3, 4, 5, 6, 7, 8, 9, R&D 3 is less than or equal to 0. Because if we invest in R&D year 1, R&D year 2, and R&D year 3 are impossible. So we'll go over in our final constraint, our 8th constraint, and we know this from the initial state, or this statement right here, 500,000 available, that we have to somehow indicate we can only invest $500,000. And that's X1 plus X2 plus X3 plus X4 plus X5 plus X6 plus X7 plus X8 plus X9 plus X10. We have 12 decision variables, so plus X11 plus X12 must be less than or equal to $500,000. Now, because we're trying to maximize our return, we know that we'll be investing all $500,000, but we don't have to add that to the equation just yet. So we've indicated that X1, which is investment year one, sales, investment year one, manufacturing, investment year one, R&D, plus advertising year two, manufacturing year two, R&D year two, etc., must be less than or equal to $500,000. Our total investment in each of those 12 possibilities must be less than or equal to $500,000. So what we've shown here in this, one second, make it as large as possible. So in this section, and I will send this document to you tomorrow, in this section, what we've indicated is we've gone through the question and we've figured out exactly what they're asking. Once we know exactly what they're asking, we have to put it into our linear equation format, our objective function plus our constraints. Once we do that, and once we take the other information, 20, 30, 50% given to us, we're able to plug these numbers into Excel and solve it relatively easily. Hopefully everybody is clear so far. In section 2, using QM for Windows, I will solve this problem for you. And if you are not clear yet, hopefully that helps you to understand. Thank you everyone for your time. If you have questions, as always, I am available through Kakao. Part 2 of our video. As we saw from the first section, the key to this problem is setting it up and understanding exactly what's being asked and then putting it into a format that QM and Excel will recognize. In this section, we're going to look at QM. Now, the key here is not the solution. The solution's relatively easy if we've set up the problem properly. So let's look for a second at how to do that. As always, we click on Module. From Module, we go down to Linear Programming. We open a new file. Now, just for simplicity's sake, we'll title it, say, Thump Investment Example, and we'll say, in brackets, page 180, 181. Just in case we want to reference it in the future. Now, we saw in the first section that we have 8 different constraints. So we change this to the number 8. And we also know, and this is where it got a little tricky, because we have 12 different decision variables. Theoretically, right now, and this is the key, with no constraints, with nothing governing our decisions, with nothing restricting what we do, in that scenario, it would be possible to invest every single year in each of the 3 categories. So, our decision variables are each of the 3 possible decisions times each of the 4 years possible. 3 times 4, 12 decision variables. And we're trying to maximize. So we've set up our problem properly. We're going to click OK over here. Now, this looks a little confusing. So what we're going to do is we're going to add in our relevant categories to hopefully make this a little more clear. So this becomes R&D 1. Manufacturing 1. Advertising 1. R&D 2. Second year possible to invest in research and development. Manufacturing 2. Advertising 2. This becomes R&D 3, manufacturing 3, advertising 3, R&D 4, manufacturing 4, and finally advertising 4. So what we've done here is we've set up each of our 12 possible decisions. In year 1, in year 2, in year 3, and in year 4, we can invest theoretically in each of these 3 categories: research and development, manufacturing, and advertising. Now, we know from the question this isn't possible, but that isn't relevant yet. That only becomes important when we start looking at our constraints, because it is our constraints that govern what choices are possible. Right now, if we have no constraints, and if we look at a much simpler example, like how much do we manufacture if we want to produce or if we want to generate as much profit as possible, we manufacture an infinite amount. It's only our constraints that tell us what is and isn't possible. In this situation, we could invest every single year, every single category, but it's our constraints that will tell us what is and what is not possible. So now we're trying to maximize, in this situation, our return on investment. So we have to indicate in every year how much return on investment we would get if we invested that money in that year. So R&D 1, we get 20%. If we invest in R&D in year 1, we get a 20% return. Manufacturing, if we invest, we get a 30% return. Remember, we don't need the money at the end of the time period, we just need the maximum amount of money possible. And advertising generates a 50% return. R&D 2, if we invest in R&D in the second year, we get another 20%. If we invest in manufacturing in the second year, we get another 30%. We know this is not possible. We know that is impossible. But that isn't relevant yet because we're still not looking at our restrictions. We're just putting the theoretical numbers that we would get if we invested at that time. And if we invested, again, this is impossible, but if we invested in advertising in year 2, we'd get 50%. We continue. And again in year 4, one more time, 2, 0.3, 0.5. So what we've indicated is for every dollar we invest in each of those situations, we will receive that return on investment. Right now, there is nothing controlling our actions. We have no restrictions stopping us. what we have is a situation where we have to decide later what is possible and what is not. This is just the theoretical return on investment. And if we're going to maximize this situation, we have to know that what we are doing is based on the theoretical right now. It only becomes realistic when we add in our constraints. So let's do that now. Our first constraint is the minimum year one R&D. And we know from our question that the minimum we can invest in R&D in year one is $30,000. So we make R&D year one, and this must be greater than or equal to $30,000. That's what we've indicated here. No matter what choices we make, that at the bottom of R&D 1, it has to be greater than or equal to 30,000. So let's go on to our second constraint, and that's minimum year one manufacturing 1. Oh, we made one small mistake. I'll go back. It's not R&D total, it's R&D 1. So our minimum manufacturing year one, again, from the question, we know it is $40,000 minimum in manufacturing. So we put our manufacturing is a minimum must be greater than or equal to $40,000. More than that is okay, but in the question it mentioned diversification. So less than that is not okay. And finally, our third constraint for now is minimum year one advertising 1 over here, the minimum of $50,000. Now, this is all pretty straightforward so far. But as I mentioned in section number 1, this is where we have to indicate when it is possible to invest, when it is not. So, our fourth constraint is that X5 or M2. We know we can invest in M1 in year 1, but we can only invest every 2 years in M1. So that means M2 is impossible. We cannot invest in M2. If we invest, we can only invest every 2 years. So M2, and we'll put this up here, M2 can't invest We'll make this a little bit bigger so we can read it properly. We can't invest in manufacturing year 2. Year 1 is okay. Year 3 is okay. So what we're going to do is we'll go over here to M2 and we'll say that M2 must be less than or equal to 0. That means any investments in M2 negate the problem. It makes it an invalid solution. We're going to do that one more time for M2. So we can't invest manufacturing. Year 4. We can invest in year 1, and because it's a 2-year every 2 years, we can then invest in year 3. But we cannot invest in year 4 because we've invested in year 3. So we'll put that over here, and we'll make R&D 4, manufacturing 4, less than or equal to 0. That means M2 and M4, which are manufacturing year 2 and manufacturing year 4, must be 0. We're going to come up here and we're going to repeat that one more time because we can't, can't invest advertising. Year 2. We invest in year 1 because that was indicated that we had to do it. So years 2 and 3 are now impossible. So we go to advertising 2, must be less than or equal to 0. Come over here, advertising year 3, less than or equal to 0. Year 1 and year 4 are okay. And we know we can invest in R&D every single year, so we don't need an additional restriction. The last one that we have is we know that we have only a maximum of $500,000 to invest. We have no more money than that. So that's what we're going to do here. And that's the total for every year. Must be less than or equal to $500,000. So what we've indicated here is our 12 theoretically possible investments. And we did that with our initial 12 decision variables. We've also indicated our possible ideal solutions with each of those 12 decision variables. That means our maximum return on investment if we invest in each of those choices. Because in lines 1 and 2, that's what we've done, is we've talked about our theoretical 12, and we've talked about our 3 theoretical returns for each of those 12. Now, we also know that we cannot invest everything every year. And that's where we have to go into our constraints. So our constraints tell us what is possible, what is impossible. So our first constraint told us that the maximum or the minimum we can invest in research and development in year 1 is $30,000. Any solution that is greater than or equal or less than 30,000 is not a possible solution. We also know the minimum investment in year 1 is $40,000 in terms of manufacturing. Anything less than that would not be a possible solution. And I made one small mistake here. I forgot to change my sign. So we'll do that now. And what we've seen is in the minimum in year 1 in terms of advertising is $50,000. So we've inputted everything for our first year investments. Now we have to tell the computer what it cannot invest in. Because if it can invest in those, it doesn't validate it. So we have to say we can't invest in manufacturing year 2. Because we know from the question, we can invest every 2 years as possible. So year 1, and year 3 is possible. We also know that we cannot invest advertising. It has to be every 3 years. So year 1 we have to invest. 2 and 3 then become impossible. So only year 1 and only year 4 is possible. Now this question, one thing that was a little bit tricky was knowing that it wasn't, your investments didn't have to be finished in year 4, but you only had 4 years to invest. That was a little bit confusing, but hopefully now it's a little bit more clear. So we've entered all our relevant data. We're going to go up here and we're going to hit solve. And what we've found is when we look, and it's pretty easy to see this, is that we're going to invest the minimum in years 1, 2, and 3. Because that is, in this situation, very clear based on returns. If we get 20% for 1, 30% for 2, and 50% for 3, x1, x2, x3, then that's probably what we're going to invest. But as we reach the end of the period, we're going to see, of course, advertising is the correct choice. It gives us the greatest return on our money. So we're going to save all of our available money for our 4th year. If we put all of our advertising then into, or all of our remaining funds into advertising in our 4th year, we're going to maximize our return on investment at $233,000. The reason for this is because initially when the computer is running the numbers, it doesn't yet know as it's computing if better return on investment scenarios will come along. So it will save it until the end, till it's analyzed all possible scenarios. And then it will tell us if we invest like this, if we invest our $500,000 like this, 30,000 R&D year 1, 40,000 manufacturing year 1, 50,000 advertising year 1, and 380,000 advertising year 4, we're going to maximize our return on investment at $233,000. So we invest 500 and we'll come out with $233,000 in total. Hopefully this is a little more clear now. If you have questions, as always, I am available in Kakao to ask me anything you'd like. Thank you everyone for listening. Tomorrow's lesson will again be recorded if you have questions then, so please be aware though, it will be through Google LMS like today's class. You are required to watch it at a minimum of 90% during the class time. Thank you again. Have a great day.